This is going to be 10-4 irrational square roots. The direction to this problem is going to be simplify. And the problem is square root of 50. Now since 50 is not a perfect square, you have to find two factors of 50, where one of the factors is a perfect square. So 5 and 10 won't work because neither 5 or 10 are perfect squares, but 25 and 2 work because 25 is a perfect square. So then when you find the perfect square, you have to take the square root of it, which is 5, and you always put that on the outside of the radical, and you'll put 2 on the inside, and that's as far as you can get it simplified, so that's your answer. 5 root 2. The directions are the same for the second problem, which is going to be the square root of 48. So 24 and 2 don't work because neither 24 or 2 are perfect square roots, but 16 and 3 work because 16 is a perfect square, and the square root of 16 is going to be 4. So 4 goes on the outside of the radical, and 3 goes on the inside. So the answer to that is going to be 4 root 3. Directions are going to be the same for the third problem, and it's going to be a little bit bigger. It's going to be square root of 320, but you can do a ladder. So 320, 4 it's going to be 80, 80, yeah, and then 4 it's going to be 20, and 4 it's going to be 5. So 4 to the third power times 5 is the same as 64 times 5, and the square root of 64 is going to be 8, so 8 will go on the outside of the radical, and 5 goes on the inside since it can't be simplified anymore, and that's your answer. 8 root 5. And then you also have ones where it's like there's already one on the outside. The direction is the same, simplify. 2 root 96, which is the same as 2 root 16 times 6. 16 is the perfect square, so you take the square root of that, which is going to be 4. But since 2 is already here, you have to multiply 2 and 4, because 2 is already there, so now you're taking out another square root. So 2 times 4, and 6 can't be simplified any further, so 8 root 6 is the answer. And then you could also get ones that are in fraction form, so like 5 over 16, where 5 can't be reduced anymore, so you'll leave that inside, but 16 can, but since it's in the denominator, you have to put 1 over 16, and the square root of 16, which is a perfect square, is 4, so you do 1 over 4, so that means you're going to put 1 over 4 outside the radical, 5 on the inside, and that is your answer. And then the next one is going to be 0.72. So you still have to do the same thing, even though it's a decimal, find two factors where one of them is a perfect square, times 2. That would work because 0.36, even though it's in a decimal, 0.6 is still its square root, and it's a perfect square. So you take out 0.6, put that on the outside of the radical, put 0.6 on the outside of the radical, and 2 on the inside since it can't be simplified anymore, and that's the answer. And then that's it for there, and now the directions are going to change, and it's going to be solve. So now these are going to be equations, and the way to solve these equations with these squared signs in it is going to be the same as before. So you just ignore the x squared and treat it like it's a normal equation. X squared, and that's going to equal 60. Now you square root both sides. So basically you're square rooting 60, which is the same as 4 times 5. 14, right? 4 times 15. And where 4 is the perfect square, so then 2 would go on the outside of the radical, 15. So then x equals 2 root 15, and that's the answer. they could also give you ones where it's like square root of 432 minus 2 over, let's do it far away, minus 2 over 3. In this case, you would need a calculator. So what you would basically do is this. You would go here, and then you go 432 parentheses. Make sure you don't forget the parentheses, otherwise it's square rooting the entire thing. Minus 2 equals 18.78460969, and then you divide that all by 3, which is the denominator, and that gets you 6.261536564, and you always round to the nearest thousandth. So the answer here would be 6.261 after rounded. It's going to be about that. And that is all. I hope this helped.